everybody, Johnny Bannon here with Trepa Technologies, and in this video we're going to finish up our ACL section by going over and configuring extended ACLs. We're also going to configure named ACLs, but they're going to be extended because we're going to filter based off port and protocol this time. So if you've been watching our CCNA series in order, we just got done with our standard ACL lab. In this extended ACL lab, now things are going to switch up a little bit. Now we're going to be able to filter based off the actual port or protocol. We're going to be able to filter from source to destination. And we're going to want to place our ACL as close to the source as possible. This is compared to a standard ACL, where we have to place it as close to the destination as possible. So with this lab, again, same thing. We have the same network diagram, and we're going to use that link in the description below if you're on YouTube to go to our GitLab repo to follow our extended ACL lab. In our extended ACL lab, we're just going to do two simple filterings. One, we're going to deny SSH and apply it to a VTY line. And then we're going to deny telnet and HTTP traffic on port 80. So we're going to use extended ACLs for this, and we're going to do one named. And of course, during this lab, we're going to go over some show commands, do some verification. Don't know if we're actually going to do some Wireshark captures this time, since we did that in the previous lab. So if you want to check out in-depth packet capture, check out the standard ACL lab. Here, we're just going to focus on creating the extended and applying them correctly. So with that being said, put this mic down and let's go ahead and get started into our lab. First, let me just zoom out my face. There we go. Put me in the corner over here. And then let me just bring our GitLab instructions into view. So as you can see here, we have the same network diagram. Behind the scenes, just like with our standard ACL lab, is we have a lot of things pre-configured. So we have OSPF routing between our routers. Our switches are configured as trunks, and we have all the VLANs set. So of course here we have something called ROAS, router on a stick. Trunk port here. Access VLANs created here, here, and here. Trunk port again right here. Sub interface or ROS, router on a stick. Then we have our IP addressing here, and we have OSPF between our two routers. If you don't know how to configure anything that I just put up on the screen, check out our videos in the previous sections of our CCNA course. Here, we're just going to focus on our extended ACL syntax and how to properly apply it. So as we see here, our security standards. In our first security standard, we only want the engineering VLAN 20 to have access via SSH to R2. So that means we just want to permit this subnet right here going to port 22 inbound on this router. And since we're doing SSH, we can apply this on the VTY lines. Those VTY lines are what accept remote connections like Telnet and SSH. So we're just going to apply our extended ACL to the actual VTY lines on R2. That's as close to the source as we can get. And our second security standard, we want only users from VLAN 10 and 20, users from VLAN 10 and 20 should not be able to telnet or make HTTP connections to the web server. So with this, we can be very granular. What we can do here is just make an extended ACL that just denies that web traffic and the telnet traffic just to this host. So when we create that extended ACL, we're going to put our source IP addresses as these subnets, and then to the destination of this singular host IP. And then we're going to deny on port 80 and port 23. Okay, well, I'm going to show you that you can either put on the ACL syntax www or the actual port number 80. Okay, either one works, and when we get into the CLI, we'll go over that. Now, I'm going to bring this lab instruction off to the side here to the monitor you cannot see, and let's go ahead and get started. So now, let's go back to our lab environment, and we're going to console into everything. So I'm going to pull up my secure CRT sessions, and we're going to start off on R2 because that's where we're going to first only allow SSH traffic from the engineering VLAN. So we're going to do this as an extended numbered ACL. And so that syntax is here, access list, and then we have our ranges. So our extended range is going to be 100 through 199 or 1300 to 1099. We're not going to go any other of these different ACLs. We're just focused on standard and extended. So I'm going to number it 130. Then I'm going to permit And check this out. Now we have a bunch of different ways we can permit besides just IP. So we're going to do just TCP because it's SSH protocol is TCP. And then we're going to do our source subnet, which is 10.10.20.0 with a wildcard mask of 000.255 to /24. Then our destination address is going to be any. So essentially what we're saying here is from this source IP addresses, they're going to allow the SSH to any. Because R2 is like an object, not just a subnet. If we want to do it like per subnet, we would have to do every single IP address on that router. So here is just any, because we're just permitting any SSH traffic from this subnet. And now we have to say to what protocol. So we're going to say equal here, equal to this port number. And look at all of our options here. We're going to see if we can type in SSH, and we can't. So that's unrecognized. So for here, we actually have to put the port number, okay? So we're going to put 22. And now, since there's an implicit deny on any ACL, we don't have to do a permit, or excuse me, a deny any. It's already implicitly there. So what I am going to do is put a log command here. So I'm going to no out this command, up arrow, and then put log, because we want to log it for sure. And now, since we're just denying SSH, we're going to go into our VTY lines and type in access class 130 inbound. So now we're only permitting SSH traffic from this IP address. Okay, awesome. Now under security standard 2, well, we're only going to allow, or excuse me, we're going to deny telnet and HTTP connections to the web server from both our VLANs 10 and 20. So again, we're going to do that on R2 because that's as close to the source as possible. That's where those VLANs are hanging off of. So we take a quick look. We're going to make this ACL and apply it inbound on ETH00. So anytime any users from this subnet try to make a telnet or web connection here, it's going to come inbound first on ETH00, and we're going to deny it there. And since we have sub interfaces, we're going to see how this is going to work out. Do we need to apply this ACL on each sub interface? And we're just going to see what we need to do, okay? All right. So first we have to make the ACL, and we're going to do this with a named ACL, which I think should always be your preferred method. And that's because with this name, we can name it, and it makes it administratively a lot easier to see what that ACL was made for. Because with just a number, you don't know, right? Access list 10 could be anything. And something I forgot to do here, guys, is actually say if it's extended or standard. Because if you're doing named, those numbers don't mean anything, right? 1 through 99 is standard. 100 through 199 is extended. When you're naming it, you have to actually say what it's going to be, okay? Standard or extended. So with this extended ACL, now we're going to do our deny statements. We want to deny web traffic on port 80 and telnet traffic. So we're going to deny TCP from this subnet. And the destination is going to be our actual web server. So we're going to do 10.10.9.20. And it's a /32 because it's a host address. And now we got to put equal to. And here we can actually put www, okay? So instead of putting the actual port number, we can do www. We're going to up arrow and do the same thing for VLAN 20 subnet. Come over here, 20, and then hit enter. And then we're going to do the exact same thing, but now we're going to deny telnet traffic. So we're going to do the port number for that. Boom. And now we're good. And then we're going to do permit IP any. And why are we doing this? Because of that implicit deny. And now we have to go into the actual sub interfaces, because if we take a look at our interfaces here, this is the default gateway for those VLANs. So we wouldn't put it on this physical interface because there's nothing actually coming inbound on there. Inbound traffic from our LANs, our VLANs that are connected here, are coming onto this sub interface and this sub interface. So what we're going to do here is type in interface ETH00.10, and I'm going to make sure I don't have any typos. and then we're going to type in IP access group, and then we're going to have to give the name. So if you forget the name of your access list, you can type in do show run pipe section access, and you can see the name right there. And now we're still under our sub interface configuration mode. So we're going to type in IP access group, deny HTTP telnet to web server. I'm going to highlight that and right click, inbound. And then we're going to do the exact same thing on this sub interface. It's going to be IP access group, this name of our extended ACL. Let me just highlight that again and not mess up my right click, inbound. And there you have it. Now we've applied both our extended ACLs, one named, one not named, one to an interface, and one to our V2I lines. So I believe that's it. And then again, we could go through our testing here, but for this video, we're just going to make sure we know how to apply these extended ACLs. If you want to see how I tested and verified, go back to our standard ACL video, where we actually did a lot of Wireshark captures and looking at the different source and destination IP addresses there. All right, guys. So that's going to be it for this video. I want to thank everybody for viewing. And if your unit or organization is interested in Trepa Technologies coming out to do any in-person or live virtual training, please look at that description, hit up me or my team, and we're also an Army Ignited vendor. So even if your unit does not pay for in-person training, you can also use your $4,000 a year to come to our CCNA or CompTIA training. So if you're interested in that, look at that description below, reach out to our team, request a quote from us. I want to thank everyone for viewing, and do not forget to like and subscribe.